All right, so I think I'm recording. I've been having a lot of difficulty. I sure hope that it is. Um, let's take a look. Some people asked me today to go through to help identify the domain and range, really given a graph. I don't think that there's very many people that have difficulty with these first few problems because it's given us to us this relation is a finite set. A relation is a set of ordered pairs. The domain and range is a set. The domain is a set of x values, which is the first number of each ordered pair. So I have a 6, I have a 3, I have a -2, I have a 9, and I have a -5. You can list those in any order, ascending, descending, or you could do just like I did and just read them off as in the order they were presented. You do not want to have any numbers listed more than once. Once you're in the set, you're in. You don't have to repeat yourself. You don't have to say it louder. It's in. So let's take a look at the range. It's a set of y values. We've got -2, 1, 4, -7, and 8. All right. So that is the domain and range of this relation. Take a look at the next one. Same idea. They give me a finite set. This relation is a set of ordered pairs. The domain is not ordered pairs. It's just the set of x's. -5, 6, 2, 0. You could have those listed in any order that you'd like. For the range, -5. It is considered incorrect to list -5 a second time. And hey, all the y values are -5. So we just say that the range consists of the number -5. You don't have to say -5, -5, -5, -5. We have the same idea here, a finite set of points. They've just given it to me in a graph. So let's see if I can read off the coordinates here. -5, -3, 0, -1, 2, 3, 0, 6, 1, 8, -4, +8. So the domain is all the x values. So I'm just going to read this from left to right. -5, then -4. Now, I have two points that have an x coordinate of 0, but I'm only going to list 0 one time. Then I've got then I have 1. And then I've got a 2, and I believe that's it. All right. Now for the range, I'm going to come at it from below and list the y coordinates. I've got -3, a -1, a +3, a +6. I've got 2 points that have a y coordinate of 8, but hey, once 8 is in the range, you don't repeat yourself. Once it's in, it's in. So there's my domain and range for this relation. A relation is a set of ordered pairs. Whether it's given to, every graph is a set of ordered pairs. Even when they connect the dots, it's just infinitely many points. We won't be able to list them like this. So this graph is a relation, and I can describe the domain and range of this relation using interval notation or set builder notation. Here it's telling me to use interval notation. So when I have these arrows here, it's giving me two pieces of information at once. It's giving me information about the x's and information about the y's. All of these, basically all of the points are doing that. Each point is x comma y. We need to separate the idea of x and y. So you will have some people say that take a flashlight and shine it from above, and the shadow that projects down on the x-axis, that's going to be your domain. Sometimes that's hard for people to visualize. What I often do is just tell people to make a table and extend your table and see if you notice a pattern here. So if you were to construct an X and Y table, well, let's look out at far away from the origin. And let's imagine, too, that in a second we're going to extend that even further. So if I come out here like at, I don't know, at -8, maybe we would say that -8 has a coordinate of 10. And if we come over here at +8, it looks to be symmetrical. It looks to be an even function because it's symmetrical with respect to the y-axis. So at 8 at 10. So the -8 and +8 are definitely in my domain. Well, what if I extended this line way out here? What if I looked at 20? Well, then I'd come up and I'd read this coordinate. And what if I extended this over here to -20? You know, well, I would extend this and I'd read off that y coordinate. So definitely, my graph isn't big enough to do it, but I know that 20 is related to some y value. I just, don't have a way to read it off that graph. Well, what if this instead of going out to 20, what if I went out, to 200,000 or 2 million? I would go up and I could still read over the y coordinate. What if I went further out to the right? What if I went way out here to the right? So these x's over here, I'm getting as big as I want, and down here the same idea. So when I see these arrows and I split this up into two pieces of information, the left and right is what I want for the x's, and this is telling me that I can extend this out and I can have x's as small as I want. -2 million, -2 billion, -2 Google, whatever that is. This guy over here, +infinity. So this parabola, and in fact all parabolas, if I have a parabolic function, a quadratic function, I know the domain is all real numbers from -infinity to +infinity. Now I also know that parabolas either open upward or downward. So down here, I'm interested in the coordinates of this vertex. When I'm figuring out the range, I'm specifically interested in the y values. I know that there's no portion of this graph that's below this vertex. So if I can see that there, the x coordinate is 0 and you've gone down -6. So if I come, remember that in interval notation, it's a small number comma a larger number. So I know down here that this endpoint is -6. And whether I take this y value of -2 or on the left, this y value of -2, once you're in the set, you're in the set. I'm going to keep going until it's going all the way up to infinity. Now, this -6, since that 0, -6 is a point on my graph, -6 is in the range, so I need a bracket there. Let's make this big so that we can see this. In the past, sometimes I have accidentally saw this as an arrow, and that's a solid dot. So I'm interested in the coordinates of this point, -8, comma, +6. And over here, this arrow is going there, but it doesn't have a component that goes up or down. This is just going out to the right to infinity. So when I go to figure out my domain, the x's, I don't have any point on the graph that's to the left of -8. And since that's a solid point, of all the infinitely many points on this graph, you can search forever and you'll never find an x coordinate that is smaller than -8. You'll find one that equals -8 right there. Now, all these points keeps getting bigger and bigger and bigger. I can look for a maximum x value way out here to the right, 2 million, 2 billion, 2 Google, whatever. Now, so there's my domain. I'm going to erase everything, so hey, write that down. Now the range is up and down. Well, this time I know that there's no point on my graph that's below this dashed line. I know there's no point above this dashed line. Well, this had all the y coordinates on this horizontal line are 6. All of the points on this horizontal line are -1. So I know that I have points on the graph that have a y coordinate of -1, and no point on the graph is below -1. I know that I have points on the graph that are bigger than -1, but when I get up to 6, I do not have a point on the graph that has a y coordinate that is bigger than 6. I know all of the y coordinates on this red, graph here. Any point you find will have a y coordinate that is bigger than or equal to -1 and less than or equal to 6. So there's my range for this problem. All right, we have another parabola. Now, it's not a function, it's opened on its side. And so when I said that parabolas always have a domain of all real numbers, that's if they open upward or downward. Here, if it opens to the left or to the right, the range is going to be all real numbers. Let's take a look at this arrow. It gives us two pieces of information. It tells me the x's are going to positive infinity, but the y values are going up here. The y values are going down here. Here's my vertex that has coordinates -3, -4. Now, domain is left and right. Domain is the x coordinates. I do not have a point on this graph that's to the left of this point. All of the points on this graph are to the right of that point. All day long, I can sit here and find points on this graph that all of them have an x coordinate that's bigger than -3. The only one that has exactly x equals -3 is at that vertex. So my domain, take the x coordinate of the vertex, and it goes all the way out to positive infinity. Now, the range, as I come at it from below, there's a -infinity. I go up through the graph. I'm looking at all these y values, and the range is all real numbers. All right. Now, this doesn't have arrows. It's got a hollow point and solid point. So I know, as far as left and right goes, that all of my points are between -5 and 0. There's no point on this graph that's to the left of -5. There's no point on this graph that's to the right of 0. So my domain has endpoints that are -5, and the x coordinate here is 0 because left and right. Now, since this is a hollow point, -5 is not included in my domain. The point -5, 0 is not a point that's shaded and stuff. So it's not on the graph. So -5 is not in the domain. Now, 0, 5, that is, coordinates of the points are parentheses. That 0, 5 is a point on the graph. 0 is in the domain, so I need a bracket. Now, when I'm doing my range, I'm thinking up and down. So I've got this vertex. Well, that vertex is definitely on the graph. I'm interested in the y coordinate. I'm not interested in the -3, but I am interested in the -4. There's no point on this portion of the graph that's below that point. -4 is the smallest y value. The biggest y value is up here at 5. And that's a solid point. I don't have any point on this graph that's above that point. I have a few y's that are repeated, but remember, you don't list the repeats. So using interval notation, this is my domain and range for number 7. Now, here we have a sinusoidal graph, and this wave pattern continues. We're to assume that it continues. So if this wave continues, if this guy is continuing to be a wave, it's continuing forever. So the x's are just getting bigger and bigger and bigger and bigger. So I know that x is going towards positive infinity. If this wave goes in the other direction, and as this wave goes to the left here, the x values are getting far away from the origin and they're heading towards negative infinity. So I know that the domain of this function is all real numbers. That wave extends on to the left forever and to the right forever. Now, as far as the y values go, I've got these max and min points. I do not see any point on this curve that has a y coordinate that's above that line. And on that line right there, all of those y values are 3. Well, I need to go small number comma larger number with interval notation. So let's come down here and maybe start with this one. All of these vertexes down here, all these min points, have a y coordinate that looks to be -7 if I'm seeing that right. So my range has the smallest value of -7, and it has infinitely many points that have, I don't have to list -7 infinitely many times. Well, I can't list it infinitely many times. And up here, all of these points all have a y coordinate of 3. But never do I see a point that has a y coordinate that's smaller than -7 or bigger than +3. So there's my domain and range. Hope that helps, and I will talk to you later.